Welcome to lecture 14. We will talk about chances. I'm your instructor, Miss Laura Lowe. That's our last lecture in week 5. So when you heard about finding chance, we will talk about probability. Before moving on to our topic about chances, let's do a quick review from the last lecture. At the end of last lecture, we talked about iteration. We introduced you the for statement. So the for statement is the keyword that begins a multi-line for statement. Execute a for statement, perform a computation for each element in a list or array. The reason is, we see here, the autonomy of a for loop. They will repeat to do something like earlier we say the for statement, the keyword is before a multi-line expression. So then they will repeat this part how many times? Depends on the item in an array. So usually here we just say for item in some array. Then here can be list, can be array. Depends on what the data you may need to perform for the operation you want to do here. So here they say item, just you can give them any variable name. So then depends on how many elements in the array. So then we will perform how many times. So usually here we just say the print. It can be just a print function, but also we just can consider that some operation. You just need to replace the item with the value in each element in the array. So that's our for statement. So that's a common special case to perform a computation of fixed number of times. Python is very easy to do. So basically when we talk about the for loop in other programming language, we just typically mean how many times you want to perform something. But one thing, since we have the list and the array, the data type can be different. They replace that value in the operation we want to do. So that make the for statement can be more easier to perform the operation you want to do. But the same thing, let's back to see the Jupyter Notebook example. Let's quickly review the iteration we talked about last week. So here is the example we say if we want to perform for the certain time. So you just see here, you make an array. So we use the np.arrange. So 5, then create array is 0, 1, 2, 3, 4. So you kind of perform 5 times. So for this I, maybe we just print the I. So if we don't want just print the number, just print certain string 5 times, we can do that as well. So with for I just kind of a value to holding each element in the array. Sometimes they will apply for the statements after the for statement, or they just not included in there. So in this example, we just don't need the I, but we print Go Bears 5 times. Okay, so that's the iteration we talked about last week. And also we talked about how to append the array. Okay, so you remember here we create an array. So 2 and 3. So then we just, if you want to append 4 at the end of S, so then you can see here. Okay, so you can see here, you pass in the S, but you see S still 2 and 3. Why? Because you just passing the array, you want to append something, but you didn't do reassignment. So if you want to do the reassignment, that's why here, right, S is on 2, 3, and 4. Okay, otherwise, it's like here. Yeah, then they didn't do anything because you didn't reassign. But here also we need to print S. Okay. Okay, so then we can append S 4 again. Okay, so now you have 2, 4. Okay, so don't forget, if you want to append, you need to reassign to the either another array or, but like we say, you want to append, right? So you just assign to the original array. So so here we have an array 2, 3, 4. If we want to do append a number to the array certain time, okay, so you need to write a for loop. So here we do 5 times. So each time we append, we not only append 4, 5, something like that. We just append for I equal to I start from 0 until 4. We just multiply by 10. So that's why at the end we just append 0, 10, 20, 30, and 40. So then we display the result. Yeah, so that's the for loop example, right? But quickly, we talk about the for loop example, and last week we also talked about the simulation. Okay, if you remember, we tried to see rolling a dice to compare the number. Your number is greater than me, then you win. I greater than you, I win. So remember, we do it 100 times to see who win and how much money we lose or win. So let's do another simulation. Let's toss a coin. Yeah, here actually we can say you toss a coin 100 times, or you toss 100 coins at the same time and want to see how many heads, how many tails. So how to do that? Remember, we can use np.random.choice. But one thing, the first thing you need to tell me before you do the np.random.choice, what kind of outcome you have. So we toss a coin. We either have heads or tails, right? Okay, so that's our coin. So that's our outcome. Okay, so that's why here is you call np.random.choice. You pass in the outcome. Okay, so they will either be tail or heads. Okay. So one thing is, okay, this one is heads. Yeah, you can run many times. If you want to toss 10 coins at the same time, right? Equivalent to you just run 10 times. But good thing is, np.random.choice, they have the second optional argument. You can tell me, yeah, how many times you want to perform. So I want to perform to toss a coin 100 times, or toss 100 coins at the same time. Right, the output we got here, you have 100 elements. Okay, either heads or tail. That's good, but how many heads in that 100 times? Yeah, we need to count one by one, right? So do we need to count? Right. Last lecture, we also told you, you don't have to just count by yourself. We just check each element. Okay, so here is the 100 times. You got the array. So each one we just compare. If I want to know how many heads now, yeah, we just compare. Are they equal to heads? If equal to heads, they will return true. So you sum that array, the ball array. Okay, so then you can get total how many heads. Okay, so that's good, right? So on the other hand, we also can write this one. Yeah, sometimes we run, we toss 100 times. Maybe we just make them become an N. Okay, I want to know how many heads according to how many coins I tossed. So then I define a function. So they will return, yeah, here is the np.random.choice. Then you tell me, you give me the outcome array. Then how many times you want to perform. So compare, are they equal to heads? Then I will give you this n times how many heads you have. Okay, so that's define this function. After you define this function, what the good thing is, okay, just for example, I want to do flip 100 coin to get the result each time. Okay, but I'm not only flip 100 coin one time. I want to do 10,000 times. Okay, so decide how many times you want to repeat the experiment. So if this experiment we define in the num of heads, you can tell them how many coins you want to toss. Then I want to do 10,000 times. Okay, so this one, right, we need to write a for loop. Okay, so this for loop tell me how many times you want to do. So I want to know the outcome. So every time you do one experiment, so that means you toss 100 coins. I want to get an array. I want to get a result. So this result, how many heads in there? I create an outcome array. Okay, remember we say if you want to get outcome array, we want to append the outcome, right? So you call np.append. So the first one, the outcome is the array to keep those results. So what kind of result? Toast 100 coins get how many heads? So they will add one more experiment result at the end of this outcome. But don't forget, you need to reassign your result in this array. Okay, so for example, what you will get? Okay, repetition, we didn't run this one. Okay, so what result you will get? Oh yeah, because we didn't display. Okay, so if you want to see right here, you need to display the outcomes. Okay, so we look at this outcome. Yeah, because you do 10,000 times. So they give you a 10,000 element array and see how many heads each time. It's difficult to see, right? Right, so that's why we want is what? We want to visualize that. And we want to visualize that. You visualize that, then we need to create a table. So we make this array into a table. So the column label is heads. So that's the outcome. So I want to see those value, right? Okay, so that's again, what kind of value this one is? This heads column is numerical number. Numerical number, we want to see their distribution. We need to have the histogram. Okay, so this histogram, I want to show you. How about we just don't have thing yet? Okay, so we just run. Okay, so that histogram look like this. Okay, so the other thing is histogram, if you didn't specify, they just random choose the interval for you. So earlier we show here is the reason you can see they are kind of just in between, like 35% to 60%. So that's earlier we have the bin here. Okay, mostly they are between 30 to 70. So that's why they make another range here. And also the bins, they will, according to the value here, we make a little smaller unit. Okay, so that will be easier to see. So you can see here, they are make each one is 1 bar. Yeah, so 50, usually you see you toast 100 coins. Yeah, heads and tails. Supposedly they are even chance. They should be 50-50. So that's why you can see, 50 not the highest one, but not too bad either, right? Because you see, 49 heads or 51 heads, they are the next highest frequency. And also when you go to like only like 30 tails, they're almost like 0. Okay, so this one is we call the bell curve. So this bell curve is most of the time when you do the random experiment, okay, they will approach to, as many times as you do, they will approach to the bell curve we call the normal distribution. Okay. Of course, if you want to run again, you can see here, they still the same, very close to the bell curve. The 50%, this one is even more. They are the highest frequency. So that's we say the even chance. When you toss 100 coins, okay, we know the tail and the heads, they are 0.5% chance. But they are not always 50-50. But after you run 10,000 times, okay, so each time they are individual results. But if you run the times big enough, the most frequency will happen to the 50-50 time, 50-50%. Okay, but we still cannot say nothing will happen other than 50-50%. So probability actually is an important thing for data science. This we call finding chance. The basic is what? You have one thing we call that's events. If one event happen, okay, they are between 1 to 0. If your chance is 0, that means it's impossible happen. If your chance is 1, that means 100%. That means it's for sure it will happen.